evening, students. Can one of you indicate if I'm audible? Can you guys hear me? All right, thank you. Brilliant. I am Dr. Nutai, and I'll be with you for the rest of the semester for basic numeracy skills 2, which is for everyone who's doing BNU 1501. So I hope everyone who's here is doing BNU 1501. Okay. So I'm going to leave an email for like the contact details of Mr. Beaumont, who is going to set up the one-on-one consultations if you guys are in need of one-on-one consultations. If you need help with anything that is specific to the module, even if you need help with your assignment, he's the one who can set up a meeting, and then we work out the problem for you. Okay. Today I thought we would start. Hello, Mr. Beyond.
Oh, finally. There's an echo somewhere. No, I was busy doing your introduction and then you came in, so I'm not sure if students heard me. If students could hear me, I don't know if the students can just indicate if they heard me. No. Okay, so can I just do the introduction and then you can continue? I just want to let them know about the services and that kind of thing. Is that okay?
That's okay. That's okay.
Okay. It's gonna take 2 minutes. Good evening. Thanks. Good evening, students. My name is Avron Beaumont, and I am part of the academic support team in the Eastern Cape region, specifically in the Gqeberha office. My job is to ensure that you successfully pass your modules, or at least try to help you pass your modules successfully. Within academic support, we've got tutorial support, which will focus on your content. Then we've got academic literacies, which is a session like this, which focuses on the skills you need to pass your modules. Then we have library services and counseling services. If you need any assistance in terms of any of those, you're welcome to contact me and I will then direct you to the correct people. These sessions, you will see, you've received emails about it. Where I've put it in your calendar, you can just accept it and then it will be there. So there's a session today. So what I will then do is this link is the link you will use every time you join for BNU. Okay. The recordings for the session should be available at 48 hours after the session takes place, 48 working hours after the session takes place. And you are welcome to contact me if I slip up or anything like that. And then with regards to consultations, we do have one-on-one consultations available. Doc, you didn't share times for me, so perhaps you can just give specific consultation times, and then students can also be aware of that. And then you just email me with the times, and then I'll set up the form so that we've got the consultation sorted out. We also have what we have called the Early Alert Student Support Program. And this is after, like when we see that after your first assignment, perhaps you did weak or your marks were weak or anything like that, it puts you at risk of not passing the modules, then we would like to come in and contact you. If you would like that kind of support, please do not hesitate to contact me. If you need additional support, please do not hesitate to contact me. If our region cannot assist you, then we will try to find a region, whether it's Western Cape, Northeastern, or whatever, and they will then try to assist you. Just some house rules. I have disabled everyone's mics and cameras so that there's no disturbances. So, Doc, when you want students to unmute, then you can just enable their microphones, and then you can disable it again, just so that there's no disruption for the recording for students who might want to do asynchronous learning. I'm also going to be putting a survey in the chat where you can where you will then rate how to this evening session went, and then you can also say what you would like us to improve on. That is just so that we know exactly that our services are fit for purpose. With that being said, Dr. Natai, all the best with your session. Students, all the best for the semester ahead. Yeah, so I'll be hovering around. If you need anything, call me in or whatever. So yeah, anyway,
Okay.
best of luck, Doc.
All right. Thanks, man. Thanks. Okay. Okay, let's just jump into it. Um, okay, I'm gonna ask you guys to please indicate if you can see the slides. Like I see,
I think it's loading, Doc.
it's loading. Okay. Okay. Thanks.
Dr. Natai, it's not loading. So don't you maybe want to unshare and then reshare?
Oh, okay. Okay. Let me do that.
Dr. Notai, I see you're still not sharing, eh?
Okay, is it still not showing?
No, it's visible now, Doc.
It's visible.
Can
Oh,
you hear me,
thank
Doc?
you.
Yeah, it's visible. Okay.
Okay, all right, thanks. Thanks. Oh, okay. Simplifications for simplification of algebraic expressions. Okay, just a few things that you should expect. So after the lesson, you should be able to distinguish between different types of mathematical expressions, and also we look at simplifying complex algebraic expressions. Okay, let's get into it. Okay, there are a few steps involved in the simplification of algebraic expressions. So when simplifying algebraic expressions, it's always important to remember to follow the order of operations. The order of operation is a set of rules that dictate what order the operations in an expression or equation should be performed. So the order of operations rules are the first parentheses are completed first. That is that the first the first one you deal with is the parentheses, then the exponents next, in the order of left to right, and also from left to right if they are involved in an expression. And then the last one is addition and subtraction, or from left to right. So the order of operations is often abbreviated as PEMDAS, must be followed when simplifying any expression, whether it's a numerical or algebraic expression. My next slide. Okay, what does it mean to expand an expression? So sometimes when simplifying an expression, it is necessary to first expand. The expanding an expression means rewriting it without parentheses or the brackets. If the expression is a numerical expression, the operation inside can be performed. So for an example, in the expression 5, the sum of 7 and 4, which is 7 plus 4, and then multiplied by 110. So the first thing, remember we said we will deal with the brackets first. So we perform the sum, the sum that is inside the brackets first. So we add 7 and 4, and then we perform the multiplication from left to right. For an algebraic expression, the distributive law applies. The distributive properties may be described as follows. So we've got A multiplying on the side C plus C. The first thing you do is the distributive law says the number that is out, or the variable that is outside the bracket, will multiply both of those that are inside the brackets. That is, you will have A multiplied by B, A multiplied by C, and then you get AB. So it will be AB plus AB plus AC, sorry. Forgive me for that error. Now the AB plus AC. Similarly, you have A multiplying on a difference of B and C. So you have A into B minus C. So you first multiply A and B together to get AB.
Dr. Notai? Dr. Notai? Sorry to interrupt you. Students say that they can't see the screen. So perhaps Anshe and Rishi?
Again, okay.
Okay, because I've joined from my phone as well, and now I can't see it on my phone. So
okay. Sorry about that. Let me stop sharing again.
okay, I can see it now. I see students are giving thumbs up.
Okay.
Okay.
All right. You know what? Oh, yeah. Because are you still going to stay on the meeting? How long are you going to stay on the meeting, Abram? Well, I'm thinking maybe.
I'm still here for now. What do you need me to do?
No, because I'm thinking about if the screen disappears again from them.
I'll stay on the meeting. Then you just share your presentation with me because I won't be home. But I can if I need to present if I need to project, so I can project via my phone. It's no problem.
Okay. So can I send it to you? Let me see.
Yeah, sure. You can send it to me. But then you can project and you can just let me know if you need me.
Okay.
Okay, because I also have a speaking engagement. Sorry about that.
Yeah. All right. It's fine.
So, but for the most part, I'm available.
All right. Okay. Thanks, man. Okay. Okay, I'm just gonna move backwards a little bit. I don't know when did the screen start disappearing from you guys. Okay, so I'll just run through a few important things from the previous slide. So, okay, so it's the order of operations. So if you have parentheses or brackets, so you deal with those first. You deal with whatever is inside the brackets first, and then if the expression also contains exponents, so you deal with those second, from left to right. And then if it has multiplication and division, those will come next, from left to right as well. And then the last one you deal with will be your addition and subtraction, from left to right. So the order is abbreviated as PEMDAS. this order is applies whether it's a numerical or algebraic expression. Okay. So in the case of come up to the next slide. So expanding an expression means rewriting it without the brackets or parentheses. Okay, if the expression is a numerical expression, so the operation inside can be performed first. That is, we deal with what is inside the brackets first. Like in the example that is given, we have 5 multiplied by open bracket 7 plus 4 close bracket multiplied by 110. So you deal with what is inside the brackets first. That is, you perform the sum 7 plus 4, and then you perform your operations from left to right. Okay, in the case of algebraic expressions, so the distributive law applies. The distributive law properties may be described as follows. So you've got A multiplying on the bracket of B plus C. So what you do first, you multiply the first entry in the bracket by what is outside the bracket, that is A multiplied by B. Now you get AB, and then A multiplied by C, you get AC. So it's going to be A plus AB plus AC. And then similarly, if you've got a difference inside the brackets, you multiply A by B, and then multiply A by C to get AB minus AC, where A, B, and C can be any numbers. So we use this property when simplifying algebraic expressions. So for example, to simplify 5 multiplied by y minus 6, we follow these steps. The first thing we do, you multiply 5 and y to get 5y, and then you multiply 5 and 6 to get 30. Therefore, 5 into y minus 6 is equal to 5 times y minus the bracket 5 multiplied by 6. So the final answer will be 5y minus 30. So when evaluating an algebraic expression, the given value could be substituted in the expression before or after simplification. So the answer must be the same. An example is in determining the value of 5. Sorry, that should be 5. That should be 5y minus 6. 5y minus 6 if the value of y is given to be 9. So in this case, you will have to substitute 9 into the expression. So you have 5 multiplied by 9 minus y to get 5 multiplied by 3, which gives you 15. You can also substitute into the simplified expression, which was 5y minus 30. To get 5 in the place of y, you put 9, so we get 45, and then minus 30 to get 15. Can you guys still see the slides? Can you indicate? Someone just indicate with a thumbs up. Okay, brilliant. So when you are not sure whether you simplified an expression correctly, you should always check your work by evaluating the original expression and the simplified expression for some values of the variables. So an example is given when you are asked to simplify x multiplied by x minus 1 plus 2x minus 1. So the simplified version will be you open the bracket first. We deal with what is we open the bracket first by multiplying whatever is in the bracket by x. So x multiplied by x minus 1 plus 2x minus 1 will be equal to x multiplied by x to get x squared minus x multiplied by 1, we get x, and then we rewrite everything else, that is 2x minus 1. So we have 2x minus x plus 2x minus 1. Collecting the like terms, we'll have x squared plus minus x plus 2x. So we have 2x minus x to get 1x, which is x minus 1. So that is the simplified version, x squared plus x minus 1. Okay, now substitute any number in the simplified version, e.g. x equal to 1. If we take x to be 1 into the expression you were given and into the simplified version. So let's start with the original one. When we substitute x equal to 1, so we will have 1 multiplied by 1 minus 1 plus 2 multiplied by 1 minus 1. So in the place where we see x, we put 1. So where did I run off to? Oh, okay. Okay, so in the place where we see x, we're putting 1. So we'll have 1 multiplied by 1 minus 1 plus 2 multiplied by 1 minus 1. So 1 minus 1, what is inside the bracket, gives us 0. And then 1 multiplied by 0 plus 2, where 2 multiplied by 1 is 2, and then minus 1. So 1 multiplied by 0 is 0 plus 2 minus 1. So 2 minus 1 gives us 1. So that expression gives us 1. So let's go to the original expression. Okay, sorry, the simplified one. The simplified version was x squared plus x minus 1. So we said we're putting x to be 1. So wherever we see x, we put 1. So we'll have 1 squared plus 1 minus 1. So 1 squared is 1 plus 1 minus 1. So we have our final answer is 1. So the answer is the same for the original expression and the simplified one. So there is a good chance that we simplified correctly. So therefore, x multiplied by x minus 1 plus 2x minus 1 is equal to x squared plus x minus 1. All right, let's have a look at some worked examples. Expand the expression by multiplying out the brackets. So here is what I'm gonna do. These are worked examples, but I want you guys to work them yourselves. Just work out on your own, and then if you get the answer, write it. Please write it on the chat section. I'll try and go and monitor it. Expand these expressions by opening out the brackets. Work them yourselves and then write your answer on the chat section. I'll go and have a look at it. And then afterwards we will compare with what I worked out. All right, guys. Let's work. I think I'm gonna just give it a few minutes to finish up. I'm gonna give it a few minutes to finish up. Share on the chat section. I see that your mics have been enabled. So if you feel confident enough to share, you can unmute. Just unmute and share with us your answers. Okay. Okay. Guys, the first expression, have a look at it closely. So we have 5, open bracket, 4f squared plus 2f plus 5, close bracket. If you look at it closely, you see that the 5 that's multiplying on the bracket is positive, and everything else inside the bracket is positive. So we know that multiplying a positive with a positive will always always give us a positive. So there shouldn't be a negative. I see just a slight error from a few people. That is a slight error that you guys have made on the answer. So it's either you made the 2f negative, or because I see that you're getting minus 10f. So the 5 is positive and then the 2f is positive. So it's supposed to be plus 2 plus 10f, not minus 10f. So that is the slight error that you guys have made. Okay, I'm gonna stop sharing and then share again. Okay, I hope it's visible now. Is it?
Yes, it is visible. Thank you.
Yes, it is visible. Thank you. All right. Brilliant. Okay. All right. Okay, there's a hand. Unmute your mic and then ask how you Ayabulela. Okay, all right. I think let me share my answers as well just compare with what you guys got. Well done. Thank you all for working. I see you guys are on track already. You guys are on track already. Well done. Okay. Let's look at the first one. Expand the following expressions by multiplying out the brackets with 5 multiplying into 4f squared plus 2f plus 5. Okay, so we said 5 will multiply throughout the bracket. So multiply 4f squared by 5 to get 5 multiplied by 4f squared plus 5 multiplied by 2f plus 5 multiplied by 5. So we get 5 multiplied by 4. You can group those that can multiply together, so that is the numbers will multiply together, and then so that we have 5 multiplied by 4 and then multiplied by f squared, and then plus we group 5 and 2, 5 multiplied by 2 multiplied by 4 plus 5 multiplied by 5. So 5 multiplied by 4 is 20f squared plus 10f plus 25. So well done, guys. So that all of you got this one right, except for that error of a negative that some of you got. So otherwise, well done. Let's look at the second one. The second one is negative 4 multiplied by 2x minus 3y. So negative 4 will multiply throughout the bracket. So we'll have minus 4 multiplied by 2x, and then minus 4 multiplied by negative 3y. Okay, so that we will have, we group the numbers together. We have negative 4 multiplied by 2, and then out of the bracket we put x minus 4 multiplied by negative 3 y. Okay, so negative 4 multiplied by 2 gives us negative. It's a negative and a positive, so it gives us a negative. So we have negative 8x. We have a negative and a negative. So the numbers negative 4 multiplied by negative 3, we get positive. A negative and a negative gives us a positive. So we get positive 12y. So that is the final answer. And well done, guys. You got that right as well. So the 8 should be negative. The 8 should be negative because it's a negative and a positive. A negative multiplying on the positive. So negative 8x plus 12y. Okay, let's go to the third one. The third one, we had 5x multiplied by x squared plus 2x plus 6. So 5x is going to multiply throughout. So 5x multiplied by x squared plus 5x multiplied by 2x plus 5x multiplied by 6. Okay, you see that 5, you take out 5 to group the variables together. So we have 5 multiplied by 2 and then multiplied by x multiplied by x plus 5 multiplied by 6 into x. So we get 5x multiplied by x is x to the power 3 plus 5 multiplied by 2, we get 10. X multiplied by x is x to the power 2 plus 5 multiplied by 6 is 30, and that gives us 30x. You got that one correct as well, guys. Well done. Okay, Number 4 is negative 2 multiplied by y plus 5. So we have two brackets, the outer bracket and the inner bracket. So what you do first, you open the bracket that is inside by multiplying on that bracket by y throughout. So we'll get negative 2 multiplied by negative 2 outside, then open the bracket. So the outermost y is going to multiply on that innermost bracket. So we'll have y multiplied by y plus y multiplied by 5. So we have, okay, we take down negative 2 multiplied by, so y multiplied by y is y squared plus 5 multiplied by y gives us 5y. And then now we can multiply by the negative 2 that is outside to get negative 2 multiplied by y squared plus negative 2 multiplied by 5y, so that we get negative 2y squared minus 10y, because the negative 2 and the positive 5 will give us the negative 10y, the negative 10. So we get negative 2y squared minus 10y. So that is our final answer. All right. Okay. Already. Right, there's an exercise, but okay, let's look at it together. Okay, simplify the following expressions. 3 multiplied by 2x squared multiplied by 8x multiplied by x, or 8xx is equal to 3, open bracket. Group the numbers together, so 2 and 8 will multiply together, and then everything else that has x multiplies together. You group the like terms. So 3 multiplied by 2, so 2 multiplied by 8 is 16, and then if you multiply that by the 3 that is outside, you get 48. And then x multiplied by x squared multiplied by x squared gives us x to the power 5, so that the final answer is 48x to the power 5. Okay, similarly on the second one, we have a b squared multiplied by a squared b squared, so that gives us a multiplied by a squared. So you're grouping the like terms, what has a together, and then what has b together. So we have a multiplied by a to the power 2, or multiplied by b multiplied by b to the power 2 multiplied by b to the power 2. Okay, so a multiplied by a to the power 2 gives us a to the power 3. And then b to the power 2 multiplied by b to the power 2 gives us b to the power 4. Okay, the third one, we have 2x squared minus the difference of x minus 3 minus 2x times 1 plus x. So this is equal to, we will deal with what is in the bracket first. So there's a negative that is multiplying on the bracket of x minus 1. So negative multiplied by positive x gives us a negative x. So that negative multiplying in negative 3 gives us positive 3. So we have negative x plus 3. We have dealt with that first bracket, and then let's deal with the second one. We have negative 2x multiplied by 1 to get negative 2x, and then negative 2x multiplied by positive x. It's a positive and a negative, so we get a negative. So negative 2 x multiplied by x, we get negative 2x squared. So we can simplify it further because we see that there is like terms and the expression. So 2x squared and negative 2x squared. So if you add those together, so you see that they are the same, but with the opposite signs. The first one has a positive and the last one has a negative. So if you group them together, you're gonna have 2x squared minus 2x squared, which will give you 0. And then let's group what has x. So we have negative x and negative 2x. So negative x and negative 2x. So there's a negative 1 and a negative 2. So it's negative 1x and negative 2x. So those have the same sign, which is negative. So you can add them, but keeping the sign, which is negative. So they are both negative, so you can add them. So 1, negative 1, and negative 2 will give you negative 3. And then you keep the variable. So you get negative 3x plus 3, which is the constant. So you get negative 3x plus 3. Okay. What comes next is the exercise for you guys. Simplify the following expressions. Just simplify the following expressions. You can group the like terms. So just group the like terms and simplify further. So you have a to the power 3 minus 2ba squared plus 10b squared a minus 5a squared b plus 14b to the power 3 minus 7ab squared. And then the second one is 30xy divided by 15x squared y to the power 3 multiplied by 2y to the power 0, and so on and so on. But in the first one, you'll notice the trick here. The trick here is the rearrangement of the variables. So you have a to the power 3. There is nothing else that has a to the power 3 in the expression. So you can just leave the a to the power. So the a to the power 3 is going to remain as it is. And then you group, you have a to the power 3. And then the next term is 2b to the, 2ba squared, 2ba squared. If you look on the fourth term, which is negative 5a squared b. So you look at on the trick there. The trick there is the rearrangement of those terms of the variables. On the first one, it's ba squared. On the fourth one, it's a squared b. But if you look at it, it's just the same, but it's just the trick of rearrangement. So those are like terms. You can add those, you can simplify those. It's the same as saying it's negative 2a squared b. The 2ba squared is the same as 2a squared b. And then the 10b squared a, 10b squared a, and the negative 7ab squared are similar as well. It's just the rearrangement of terms. They are the same, so you can just rearrange them and write the third one as 10ab squared, which will now be the same as the negative 7ab squared, which is the last one. So you can simplify those further. Okay, I want you guys to attempt. Just try and write your answer on the chat section. Are you guys winning on the first one? Are you winning? Let's see, let's try and see if we can't. Okay, my first term is a to the power 3. So if you look throughout those terms, you have a to the power 3. Then the second is negative 2ba squared. The third one is 10b squared a. Fourth one, 5a squared b plus 14b to the power 3 minus ab squared. So I got to group like terms. So a to the power 3, there's only one a to the power 3, so I can't group it with anything. So that means it remains as it is. So we have a to the power 3. Okay. Minus. The second one is 2ba to the power 2. Okay. 2b, negative 2b a squared. So is there anything else that has 2ba squared? Yes. There is a negative 5a squared b. So this term I can rewrite as 2a squared can be rewritten as 2a squared b. So it's just a rearrangement. I just rearranged the variables. So this thing is the same. Negative 2a squared b is the same as negative 2ba squared. So I've just rearranged the variables. Okay, and then let me rewrite this the next one. So I have 10b squared a. So it's always important to write your variables in alphabetic order. So a comes before b, so you have to write it in alphabetic order. So the way they stand, like negative 2b a squared, you can rearrange as negative 2a squared b. So that is the way they should be rewritten. Is this, and the second one, the third one, so 10b squared a. So a should come first. So A should come first, which is going to be 10A b squared. And then I can just rewrite 5, sorry, negative 5 a squared b, negative 5a squared b. Okay, the next term is 14 plus 14 I think the last term the last term is going to be minus 7 a minus 7a b squared. Minus 7ab squared. Let me see if I can't move that. But, to move it to this side. Okay, now I've rearranged my terms. So I have a to the power 3 minus 2a squared b plus 10a b squared. 10ab squared minus 5a squared b plus 14b squared minus 7ab squared. So now I can group everything that looks alike. Sorry, just bear with me, guys. Okay, I don't know why I'm complicating my life here. Okay, this is the simplest one. So I have a cubed, or a to the power 3 minus 2ba squared plus 10b squared a minus 5a squared b plus 14b to the power 3 minus 7a b squared. So the answer, what do we do? The first step is start by rearranging the variables alphabetically in all the terms. That is, we know that BA is equal to AB. So we are arranging them alphabetically. So this is the same thing. but now the second one is arranged alphabetically, so A comes before B. That you should keep in mind. So that whole expression rearranges to A to the power 3 minus 2ba squared plus 10b squared a minus 5a squared b plus 14b to the power 3 minus 7a b squared. So it becomes a to the power 3 minus, so the a comes before b, so a squared b plus 10ab squared minus 5a squared b plus 14b to the power 3 minus 7ab squared. So now we have rearranged the variables alphabetically. So the next step is to group the terms that look alike or that are alike. So we call them like terms. We group those together. So a to the power 3, if you look throughout the terms, there's nothing else that is a to the power 3. So a to the power 3 groups just stands alone. We can't group it with anything. So we look at the second one, 2a squared b. So there's 2a squared b. So is there anything else that is an a squared b? Yes, there is. There is negative 5a squared b. So we group that, we bring it close to its friend, which is 2a squared b. So we have 2a squared b minus 5a squared b. And then the third term was 10ab squared. Is there anything else that has an ab squared? Yes, there is. There's a negative 7ab squared at the end of the expression. So we can bring it close to the friend. So we're going to have negative, okay, so we're going to have 10ab squared minus 7ab squared plus 14b to the power 3, because it's just alone. It doesn't have a friend in the expression. So the next and the last step is to add the like terms. Let's add the like terms. So we had a to the power 3 minus 2a squared b plus 10ab squared minus 5a squared b plus 14b to the power 3 minus 7ab squared. So that becomes a to the power 3 minus 2a squared b minus 5a squared b plus 10ab squared minus 7ab squared plus 14b to the power 3. So we group those together by inserting brackets. So we take out the negative and open the brackets, because you see that it's negative 2a squared b and negative 5a squared b. So if you take out the negative, it's going to be positive 2a squared b plus 5a squared b. Or you could just say plus, it's the same. You could just, you should get the same result if you say plus a squared plus, and then you open those brackets and say negative 2a squared b minus 5a squared b. So you can have a plus outside, and then obviously inside you're going to have a negative 2a squared b minus 5a squared b. But I've just chosen to take out the negative, which is common in both. So take out the negative, then you are left with the positive 2a squared b and a positive 5a squared b. And then the next step is to add the like terms again, which is plus the 10ab squared and the negative 7ab squared can add together. So we say plus 10ab squared minus 7ab squared. So those group together, and then plus 14b to the power 3. So the next step is a to the power 3, which is grouped with nothing, minus 7, because if you add 2 and 5, you get 7. So 2a to the power 2b plus 5a squared b. So you'll get 7 of a squared b. So you just add 2 and 5 to get 7 of the a squared b's. So it's going to be negative 7a squared b. And then on this side, so 10 minus 7 is equal to 3. So you're taking 7ab squared from 10ab squared. So it's going to be 10ab squared minus 7ab squared. You are left with 3ab squared. And then plus 14b to the power 3. So that is the simplified version. You cannot add any further. You cannot group anything any further here. You're left with a to the power 3 minus 7a squared b plus 3ab squared plus 14b to the power 3. There's no further like terms. So that is the simplified version of that expression. So that is the simplified version, a to the power 3 minus 7a squared b plus 3ab squared plus 14b to the power 3. I know it's complicated. It's a complicated expression, but I think with the rearrangement of variables, just starts with your rearrangement of your variables. You would easily notice that there are like terms, and then if you proceed by just grouping those, you will get easily to the final answer. Okay, let's look at the next one. I know the next one is a bit tricky as well. The next one says simplify the following expression: 30xy divided by 15x squared y to the power 3 times 2y to the power 0. Okay, so the first thing to remember is that any number to the power 0 is 1. So that means y to the power 0 is equal to 1. Sorry about that. It should be 1. So y to the power 0 should be 1. So that 2y to the power 0 should give you 1. Sorry, 2y to the power 0 should give you 2, because y to the power 0 is 1, and then 2 multiplied by 1 will give us 2. Okay, so we have 30xy divided by 15x squared y to the power 3 times 2. So that means 30xy divided by 15 times 2. The numbers multiplied together, remember, 15 multiplied by 2 gives us 30, and then the variables remain as they are, x squared y to the power 3. And then if you divide those, so we're gonna have 30 and 30 in the numerator, 30 in the denominator. So 30 divided by 30 is 1. So the 30 on top cancels the 30 at the bottom. And then we have the squared x to the power 1 in the numerator. And then we have the x to the power 2 in the denominator. So the x on the top, so x to the power 2 is just 2x's multiplied together. So it's 2x's multiplied together. So we have 1x on the top, at the top, and then we have 2x's on the bottom. That means the x on the top, the 1x, will multiply with the one other x at the bottom. So that means we will be left with 1x at the denominator. So the other x will cancel with the 1 on top. So if we look at the y, we have 1y in the numerator, and then we have 3y's in the denominator. So we have, so y cubed is y multiplied by y multiplied by y. So y multiplied by itself 3 times. So that means the 1y will cancel the other y in the bottom. So we'll be left with 2y's. So we'll be left with y to the power 2. So 30xy divided by 30x squared y cubed will give us, so what is left on the top is just 1 divided by x y to the power 2. So that is your final answer. 1 divided by x to the 1 divided by x multiplied by y to the power 2. Are you guys following though? Or am I leaving you behind? Are you following? Okay, brilliant. Okay, the next problem was simplify 30 x to the power 4 y to the power 3 divided by 15x squared y to the power 3 multiplied by 2y to the power 2. Okay, we have two operations, which is the division and the multiplication. So we set the order. If there's a multiplication and division, we operate from left to right. So we deal with what comes first, and then we deal with the second operation. So what comes first is the division. So we perform the division first, and then we deal with the multiplication later. So we have 30x to the power 4 y to the power 3 divided by 15x squared y to the power 3 multiplied by 2y to the power 2. So we will deal with the division first. So by dividing 30x to the power 4 y to the power 3 by 15x squared y to the power 3, and then we multiply by 2y to the power 2 later. Okay, let's divide. So we have 30x to the power 4 y to the power 3 on top, and then underneath we have 15x to the power 2 y to the power 3. Okay, so 30 divided by 15, the numbers, remember we deal with the numbers first. So 30 divided by 15 will give us 2, and then we have x to the power 4 on top, we have x to the power 2 underneath. So we have 4 x's multiplied together on top, and then we have 2 x's multiplied together at the bottom. So of the 4, there's a 2 that's going to cancel with the 2 x's underneath. So that will leave us with 2 x's. So that will leave us with x to the power 2. So the x to the power 4 and x to the power 2 means that 2 x's will cancel, the 2 x's on top will cancel the 2 x's on the bottom. So that means we'll be left with x to the power 2 only. And then let's go to y. Y to the power 3 means 3 y's are multiplied together. So it's y to the y multiplied by y multiplied by y. And then at the bottom also we have y multiplied by y multiplied by y. So the 3 y's on top will multiply the 3 y's at the bottom. So it's gonna be so the y's on top will cancel the y's on the bottom, so we'll be left with 1. And then we multiply whatever is left by the 2y squared. So that means we get 2x squared. That's incomplete. So we get 2x squared times 3 Okay, so this equation should be 2 2x multiplied by 2y to the power 2. Okay, so the numbers are going to multiply together. So 2 multiplied by 2 is equal to 4. So because these are not like terms, we will leave the variable part as it is. So the final answer is 4. The final answer is 4x squared, 4x squared y squared, or 4x to the power 2 y to the power 2. That is the final answer. Okay, we're gonna look at the fourth one. Let's look at the fourth one. and then I'm gonna allow you guys to do I'm gonna let you guys to do number 5. Let's look at number 4. Number 4 is 2y squared multiplied by x minus y minus 8x multiplied by y to the power 2 minus 1. So the first thing we do is to open the bracket. We deal with the bracket first. 2y squared multiplies everything that is in that bracket. So we have 2y squared multiplied by x and minus, because 2y is positive, and then multiplied by negative 1. 2y squared multiplied by negative 1 gives us negative 2y squared times 1. Okay, go to the second bracket, minus 8x multiplied by y to the power 2. So 8x is multiplied by y to the power 2 plus, because there's a negative 1 and a negative 8. So the negative and the negative gives us a positive. So it's 8x multiplied by 1. Okay, now we look and group the like terms. So remember we said we can rearrange. So 2y to the power 2 multiplied by x is the same as 2xy squared. So 2xy to the power 2, and then minus 2y squared minus 8xy to the power 2 plus 8x. So we group the like terms, so the friends come together. So 2xy squared and 8xy squared, we group them together. So the 8xy squared is negative, so bring it with the negative sign, and then the 2y squared is no friend, so we leave it as it is, and the 8x has no friend as well, so we leave it as it is. So 2xy squared minus 8xy squared. So we have 2xy squared minus 8xy squared. So that means, you see, these have opposite signs. These have opposite signs. So we can subtract them and keep the sign of the bigger number. So we have 8x squared minus 2xy squared. 2xy squared, sorry, 8xy squared minus 2xy squared. So if we say 8 minus 2, we get 6. But the sign of the bigger number is negative. So we're going to keep the negative as it is. So we have negative 6xy squared, then minus 2y squared. So we rearrange 8x minus 6xy squared minus 2y squared. So that is the simplified version. We can't simplify it any further. So that means we're going to leave it as it is, as it stands. It's 8x minus 6xy squared minus 2y. So that is the simplified version. I just want to check the time. We've got about 10 minutes. Can you guys attempt simplifying number 4 in this final 10 minutes? Can you attempt simplifying number 5? Sorry, that is 2xy squared divided by 4x squared y to the power 3 all squared multiplied by x to the power 4 y to the power 5. Remember that there's two operations as well. Okay, there's 3. There's now 3. There's an exponentiation. Remember that we said we deal with exponents first. Okay, or let me move back right at the beginning where we had the rules. Okay. That is the bit that we're talking about, the rules of operations. We deal with what is inside the brackets first, and then we go to exponents from left to right, and then we go to multiplication and division from left to right, and then we do addition and subtraction from left to right as well. So in that expression, you see that there's exponents, there's parentheses as well. So those are your first, that is your first priority. You deal with that term that has those. So this is the term that has bracket and then exponents and then exponentiation. So you deal with this first, and then you perform your operations from left to right afterwards. So that means you first deal with the division, and then you go on and deal with the multiplication. We'll deal with this first. What is 4 to the power 2? And what is x squared to the power 2? And y to the power 3 to the power 2? We have 4 to the power 2. We're trying to open the bracket. So we will have 4 to the power 2, and then x squared to the power 2, then y to the power 3, all to the power 2. Okay, let me actually say, can you guys write this expression for me on the chat? What do you get when you open this bracket and deal with that exponentiation? What is the final answer that you'll get for this term? I want you just first write this bit for me on the chat section. 4x to the power 2, y to the power 3, all squared. I've given you a hint. It means this is 4 squared, then x squared squared, and y cubed squared. Are you winning, guys? Is it coming? I'm not gonna share it. I'm not gonna share this one. I want you guys to take it and go practice it. And then I want you to also attempt the last one. You can write this one down as well and then attempt it. And then remember that we have another meeting on Saturday, Saturday at 9:30. So I want you guys to bring me the answers to these two, number 5 and number 6. Work on them. Just try and attempt them. Just attempt. I'll want you. The first thing I'm gonna do Saturday is ask you to share the answers to these two, and then we talk about them, and then do whatever we're going to do that day. We're gonna be looking at. I think we're gonna be looking at numbers and the operations on numbers as well. So I know we started on may have started on a higher note today. So we can try and ease. I'm gonna try and ease into it. So I want to please attempt these two problems. Attempt these two problems, and then I do want to see where you are stuck. I think the time now is 9 o'clock, so I'm not gonna do anything further. I think we're gonna let's just stop today. Let's just stop for today, and then we will continue Saturday morning. Yes, the session is recorded. So I'm sure Mr. Beaumont is gonna be, like today, he's gonna be joining as well on Saturday. Even if it's for a few minutes. I'm gonna ask him to explain how do you guys get access to the recordings. But he did mention it. I don't know if there's anyone who remembers what he said about the access to the recordings. But I know that they are made available after 48 hours. So he's gonna be here on Saturday morning. So he's gonna let you guys know how to access the recordings. So on that note, thank you all for making it. We can let's meet again Saturday. Thanks, guys. Have a good evening. Please attempt those two problems and then bring the answers. All right, good night.